This episode is supported by NatWest, providing ease of mind when it comes to business payments.
NatWest Pay It, the bank's own payment solution, facilitates customer payments in near real time while allowing companies to track live spending. Need to collect payments without customer account numbers or process refunds without holding on to personal details? Pay It has your business covered.
Pay It connects directly with each customer's bank account using an API, which also allows data to be seamlessly and securely passed onto third parties. That means you can provide the best payment experience on the front end while empowering your back-end staff with the info they need for truly data-driven decision-making.
To find out more, visit payitbynatwest.com/ITPro. That's payitbynatwest.com/ITPro. There's something of a supercomputing boom happening currently, with Capitan in the USA just the latest to come online. As these facilities spring up across the world, they're breaking new ground in computing technology and prowess. But how useful is this for the average business, and what's the future of this technology? You're listening to the IT Pro podcast, recorded live at HPE Discover Barcelona 2024. Hi, I'm Jane McCallion. Today joining me is Gerald Kleyn, Vice President of Customer Solutions for HPC and AI at Hewlett Packard Enterprise. Gerald, welcome.
Jane, thanks for having me.
So you are literally just back from SC24, an international supercomputing conference in the US. Can you give us a bit of a flavour of what was going on over there?
Well, it was a fantastic show. 17,000 attendees. Wow. So a blowout year for SC. Really proud of the work that team and committee does. It's mostly a volunteer-run event, so it's a really nice community and a tight-knit community. And it's exciting to watch it grow as quickly as it is. Some of the advent of AI and its need for supercomputers has really made a change in some of the attendance there. HP is really proud, and we had a really good showing at that show because each year they release the top 500 list. Actually, they release it every 6 months. And on this month's top 500 list that they released, we had the number one showing with the Capitan supercomputer at Lawrence Livermore National Labs at 1.74 exaflops. The prior machine was at about 1.2. That was Frontier. It actually upgraded to 1.3 exaflops. And then we still had Aurora at Argonne National Labs coming in at number 3. So the top 3 machines in the world built and delivered by HP, and we couldn't be prouder to be a part of that. What's probably even as important is that we had some new contenders on the list from Europe. Mm-hmm. The system at E&I called HPC 6 debuted at number 5 on the list, and then we have CSCS at number 7 and Lumi at number 8 on the list. So the top 3 machines in Europe are also based on HPE technology. So we're really proud to be behind those systems. But more importantly, we're really proud to support the missions that those machines support, which is fundamental research, public safety, and other use cases. So really awesome use cases that our customers deliver.
Yeah, quite a good showing for HPE, certainly. And it is something that HPE has a deep background in, really, with Cray, with SGI as well. Thinking about supercomputing, so we've spoken about it a couple of times on the podcast. However, while I'm sure, hopefully we have some supercomputing listeners, not every IT decision maker is involved in supercomputing. So supercomputing HPC is very specialized. Are there any benefits from this technology for IT decision makers and businesses that aren't directly involved in it? Does it trickle down into everything else? Ultimately?
Absolutely. So it's becoming more and more relevant to more and more enterprises, especially as the generative AI workload has started to come to bear. And many companies, some of the largest companies who have large sets of data, plus service providers that serve startups that have large amounts of data or access to large amounts of data, plus sovereignties who want to invest in AI to better their populations. and they have large amounts of data. The way you take advantage of that data with generative AI is using high-performance computing techniques. So in many cases, they're building out infrastructure that looks very much like high-performance computing, with high-speed interconnects, very dense systems that can take advantage of direct liquid cooling, or liquid cooling all the way direct down into the chips and into the systems. And then building those in a clustered fashion where everything operates in synchronicity, so they can get the most performance out of those systems. Very different than a traditional IT approach where you're deploying microservices and across an entire fleet of systems or virtual machines, trying to get the most out of your operation from an efficiency perspective.
So I suppose in some ways, rather than necessarily the technology trickling down, with generative AI, companies becoming more interested in using AI in their operations, that it's almost a trickle-up effect.
For generative AI training, absolutely. Yeah. There's the inference side, and this is where, as an enterprise, you may go buy a model from a provider or utilize an open source model that you want to deploy as inference. You may go fine tune that model using smaller systems that aren't clustered, but then that's more of a scale out approach, very similar to like web hosting, where you're doing scale out as your user, or the number of tokens in this case that you need to deploy per second increases.
So you spoke just a little bit there about Capitan, about some of the kind of supercomputers that are being built out now. And it's interesting, a lot of them are there's a lot of talk about AI. Thinking about the UK in particular, we have a new supercomputer cluster that's being built. You've got Isambard AI in Bristol with HPE, and Dawn by Dell Technologies in Cambridge. So there's very much, from our point of view, that focus on AI, but our national supercomputer isn't being updated. Is it that national supercomputers are becoming less interesting and that you want more kind of specific applications, or is it just that AI is where investment is going currently?
I believe that in the UK, your AI investment was separate and apart from your national supercomputer.
Yes, yeah.
And I did notice recently that your national supercomputer ended up somewhere 60-ish on the top 500 list. So what I would say is that it's going to be important for countries to maintain and develop their supercomputing capabilities to ensure that their researchers have access to the latest technologies so that they can make discovery even faster. I mean, if you think about the speed of innovation and how it's accelerated, it's going to continue to accelerate. And for those that don't invest, they're going to be left behind. And we want to help enable everybody to compete on a level playing field, and increase the opportunity for humanity across the board. So I'd suggest that, we'd be happy to work with you guys. I know we've got a lot of great folks in the UK working for HPE, working with those sites, and we can enable whatever needs to be done to make the UK successful.
Unfortunately, it's slightly outside of my wheelhouse to facilitate that.
Anything you can do, James. I appreciate it.
So I also visited Lumi earlier on this year in Finland.
You made the trek.
I did. It was. Listeners can read all about it in my write-up, which I will link in the show notes.
Did you see the Northern Lights?
I didn't, no.
Oh, bummer.
I can see them from my garden in Oxford occasionally, though.
Wow.
Yeah.
That's on my bucket list.
Depending on how excited the sun is at any given moment and how cloudy it is in Oxford, which is overcast. But I was speaking to one of the scientists from CSC, which runs it, and about EU AI factories. So that's kind of the next step I know that they are looking at or hoping for. How do you see this initiative unfolding? Because it's a fairly new thing on the block.
Yeah, so we've seen initiatives across the globe with respect to, we call them sovereign initiatives around AI. And it's becoming more and more relevant as these new generative AI models emerge. And there's pockets and pools of data that want to stay sovereign, right? And stay within their borders and ensure that they have the right security and compliance capabilities built in. And so I know that CSC is tackling some of those issues and how they can work in a multi-tenant environment to make that work. But we've seen a lot of investment in US, like an initiative called FAST, if you've heard of that, in the same vein, where they're working to build AI factories where people can bring their sets of data, train on those, start to derive value. Because really with many of these programs, the speed to value is the really important thing. It isn't so much, am I running the latest model? Do I have the latest data? It's speed to value and speed to outcome that we like to deliver. And that's very similar to our HPC systems. How fast can we get to discovery? How fast can we get to new science? We're very attuned in that space.
I know that HPE is very proud of its direct liquid cooling and the efficiency of that. But nevertheless, we've spoken on this podcast about how demanding from both an energy and water point of view large data centers and supercomputers are. How can we square the growth in number and power of supercomputers with the challenges of energy and water resource scarcity?
Well, if you think about it, in the case of manufacturing, for example, let's say I'm a tire designer. There's two routes I can go if I've got an idea for a new design. I can go spend the time, money, and resources fabricating and iterating on that fabrication for a design where I do fabrication test, iterating all the way along. That's very energy expensive. When you go and look at that. Or I can run a simulation on a supercomputer that's minutes and consume much less power, get it done in much faster time, and actually get product to market faster and better product to market faster. In some cases, it's even more efficient product to market faster. So as an example, one of our large aviation equipment providers use our supercomputers to simulate the open fan technology. And they actually did this on Frontier. Okay. And open fan is an engine design that is known to be more efficient in jet engines, but isn't widely used because of the acoustic characteristics, especially on a commercial plane. If you have passengers, you know that if you stand behind the jet engine, you're going to go deaf in no time at all. And so this open fan technology creates those kinds of acoustics. They actually used the supercomputer to iterate on the blade design to optimize the blade for acoustics rather than thrust. But after they did that, they could still deliver 20% better efficiency on the engine while eliminating the acoustics. Yeah. So that 20%, think about that. That's 20% less fuel that an airline has to spend, which means lower tickets or more profitability, or maybe they return it to their employees, more benefit to the company, right? At the same time, it's 20% less carbon emissions from that design because we use the supercomputer.
So I suppose your argument then would be that if you just look at the supercomputer and the power draw of that, then it looks, or not just looks, it is really high. But if you look at it more holistically, then the overall energy usage of what the supercomputer is being used to do,
the outcome,
is lower.
Exactly. There's that. Now, that doesn't mean we can be irresponsible, right? We still have a responsibility to make that supercomputer operate as efficiently as possible. And that's why we've developed what we call the 100% fanless architecture. And so this is where we use our direct liquid cooling, but we do it in a fashion where we cool everything. And I mean everything. A lot of vendors stop at the CPU or GPU. We go to every component on the motherboard. A lot of vendors don't do the networking components. We do the networking components, the transceivers. You can actually see it on the show floor, but we cool everything in that system up to 400 kilowatts per rack.
I think that, obviously it's good, it's energy efficient and so on, but there still remains the water resource management part of it. In places like Finland, there's more water than you could ever need, but some places are a bit more arid, let's say, and that there is competition between local population needs and data center needs, and it's possibly one of the less looked at aspects of the problems, effectively, with supercomputing. But how how do you kind of square that circle as well?
Yeah, so, and again, we're not going to eliminate all of the use of water, but what we can do is optimize the use of that water. And so what we're doing is looking at how we can use the warmest water possible, which means you can slow the flow, which means you use less water at the end of the day. And so we're doing a lot of work to optimize that usage and reduce it as much as we can. And then we've also got some future technologies that we're looking at that takes that a step further. So we're excited that we're not just resting on our laurels. We know that there's a future where we've got a responsibility to be as sustainable as possible, and we continue to invest in that R&D.
So a nice easy one to finish on. What is the future of supercomputing?
Oh, it's bright. I mean, if you think about the basic science and the outcome that that has on humanity, and the new science that's being generated, it's continuing to grow almost exponentially. And then you add AI into that, and it's a really bright future. I'm really excited about the work that has already been done on systems like Frontier. If you get a chance, go look at the Exascale Day videos that we released. Ashley Barker from Oak Ridge National Lab does a good job talking about all of the outcome of the research that they've done. And that's what really gets me up every morning to come and work on this stuff, is all of the great stuff the scientists are doing. Now, there's also great technology coming that gets even more performance per dollar per watt. That's the metric that we have, and that'll continue to drive down the power consumption, which leads directly to some of the challenges that you brought up. So I think we've got a bright future here. It's become more relevant for more companies, and so it's good to bring them into the fold. I think you saw the popularity of SC24, the supercomputing conference, with 17,000 in attendance. It just blows my mind, and I continue to love working in this space.
Well, unfortunately, that's all we have time for this episode, but Gerald, thank you for joining me.
Thanks a lot, Jane. I appreciate your time.
As ever, you can find out more information about everything we've spoken about in the show notes and even more on our website at itpro.com. You can also sign up to our newsletter for a daily dose of enterprise IT news, features and reviews in your inbox. You can subscribe to the IT Pro podcast wherever you find podcasts, and if you're enjoying the show, why not leave us a rating and a review to help others find us. I'll be back next week with my co-host Rory, but until then, goodbye.
This episode is supported by NatWest, providing ease of mind when it comes to business payments.
NatWest Pay It, the bank's own payment solution, facilitates customer payments in near real time while allowing companies to track live spending. Need to collect payments without customer account numbers or process refunds without holding on to personal details? Pay It has your business covered.
Pay It connects directly with each customer's bank account using an API, which also allows data to be seamlessly and securely passed onto third parties. That means you can provide the best payment experience on the front end while empowering your back-end staff with the info they need for truly data-driven decision-making.
To find out more, visit payitbynatwest.com/ITPro. That's PAYITBYNATWEST.com/ITPro.